So this is my lesson, and my lesson hits on all of these standards, but the ones that I'm specifically focusing on is making sense of problems and persevere in solving them, constructing viable arguments and critiquing the reasoning of others, and modeling with mathematics. Before I go over how they tie into the 4th and 6th grade standard, I'm going to go over my lesson. So this is my lesson title. It's called A Box of Boxes. The standard is applying concepts of volume to solve problems and relate volume to multiplication and addition. And volume is introduced in 5th grade. Student learning objectives: I can investigate the volume of rectangular prisms by packing little boxes into larger boxes of my own design while trying to minimize the volume of an empty space. These are the materials and resources that I'll be using throughout the lesson. The big one is that we use a book to help us with some open-ended type tasks called Mindset Mathematics and Visualizing and Investigating Big Ideas, which is where I got most of this lesson from, and a lot of the materials and resources that I'll be using. The first part of this activity is I'll be showing students a couple different boxes. I'm going to show them this large box, and I'm going to tell them that I have this smaller box to mail inside this larger box, and show just rattle it around a little bit. Then I'm going to take that same larger box and I'm going to put another box that's a little bit bigger than the first box inside there, and there won't be as much space inside. And just simply ask them, which one would I rather mail inside this larger box? And hopefully lead that to discussion about how the one that leaves the least amount of space inside is the best one, because it won't be rattling around so much, especially if you have something valuable inside the box. So then after that, and leading to some of those discussions and questions that I have up here that I'll ask, I'm going to introduce their challenge or task. Today you'll be trying to find the smallest box that can hold a collection of smaller boxes. These are the 4 boxes, and I'll show them this little box sheet here. And so that will lead to the drawing part, or the explore, for 30 minutes. So students will work together with their math partners to design boxes to hold a set of small boxes that they can construct from cubes: a 3x1 by 1, a 2x2 by 2, a 3x2 by 2, and a 3x2 by 1. Partners will try to create a box with the smallest volume of empty space. The box must be a rectangular prism with length, width, and height. They should record their most efficient strategy that they use to find the volume of their box that fit the 4 smaller boxes, and create a mathematical argument as to how they know that they created the smallest possible box. And then just a reminder that your goal is to design a box that will hold all 4 boxes and have the least amount of empty space when packed. They can be modeling this on their grid paper using Unifix cubes to model this, or using their grid equations if they know the volume formula. These are some questions that I'll ask while I walk around and see how the students are working. After that 30 minutes, we're going to go into discuss time, and we'll bring them back together. They're going to present their mathematical arguments. Hopefully that leads to discussion of others critiquing and asking questions on the reasoning. And while they're doing that, I'm going to be recording different solutions on chart paper and asking students to look for the most efficient strategies, see if we can point any of that out when calculating volume. After we do that, I'm going to give them another 30 minutes, and this might be a 2-day lesson, but go into the second day maybe, and let them choose their own question to kind of explore. And these are the different types of questions that they might choose to go explore to extend upon this lesson. After that, we'll discuss again, and I will have students discuss their findings from their investigations, and again on chart paper, be recording efficient strategies and asking for students to highlight any efficient strategies that they use to find formula while they're presenting their arguments and critiquing others. Then we'll go into a little reflection, and this is really hitting that mathematical argument, critiquing others, mainly because of this part right here. What was your most efficient strategy for finding volume? Kind of recap, I should have a couple of different strategies on the chart paper now, and now picking the most efficient strategy. After that, we'll do just a formative assessment where they'll complete an exit ticket about how do you find the volume of a rectangular prism, requiring them to explain that, and then finding the volume of this rectangular prism. They can use their most efficient strategy. Maybe for some of them, their efficient strategy is still counting the cubes. But hopefully the goal is that a lot of them are now starting to see the formula and doing length times width times height, or area of the base times height. For my parent resources, I have 2 YouTube videos here that are linked that take you to a video of me teaching volume and the formulas that we discovered in class. And I have a link to my website where you find all these YouTube videos, where you have all my homework for the entire year and other reviews and study guides. So how does this lesson connect the 4th and 6th grade mathematical practice standards specifically for these 3, even though I do touch on all of these strategies throughout the lesson? Well, for making sense of problems and persevering in solving them, they need to make sense of this problem, just like they're asked to do in 4th grade. They need to discuss how they solve the problems, just like they're done in 4th grade. They need to listen to others and try different approaches to solving the problems. And they require using concrete objects or pictures to help them solve problems. So they're using Unifix cubes, grid paper, and stuff like that to help them solve. So they're required to do all of this stuff that's required in 4th grade. But not only that, in 5th grade, in this particular standard, they want students to relate to volume. They want students to relate to volume and also to seek efficient ways to solve a problem, and to lastly ask themselves if this problem can be solved in a different way, which we do in that explore part and in some of the discuss part of this lesson. This helps them to prepare for 6th grade, because in 6th grade, students will need to be able to solve problems in the most efficient way. So that's specific in the 6th grade standard. And this whole lesson, I'll be recording solutions, and I keep asking that question. Is this the most efficient way? What is the most efficient way that you can solve this problem? For the 3rd mathematical practice, constructing viable arguments and critiquing the reasoning of others, in 4th grade, students are required to construct arguments using concrete objects, pictures, and drawings, and explain their thinking and making connections between models and equations to refine their mathematical communication skills as they participate in mathematical discussions. Well, this lesson requires them to do all of that using their Unifix cubes, using their grid paper. They are required to explain their thinking when they're presenting their solution. This lesson builds upon that standard that they're required to do in 4th grade and 5th grade by now not only requiring students to do all the necessary steps that are above, but also then to require students to demonstrate and explain the relationship between volume and multiplication. So getting them to now see that pattern with their Unifix cubes and seeing that length times width times height formula and how it connects to multiplication. This lesson then prepares them for 6th grade, because in 6th grade, they need to also construct arguments using verbal or written explanations that are accompanied by expressions, equations, models, graphs, tables, and other data displays. So I require them to create a mathematical argument, and some of them might now be starting to use that volume formula and that written equation to help them figure out the smallest possible box that can fit that one larger box. For mathematical practice 4, modeling with mathematics, in 4th grade, students are required to experiment with representing problem situations in multiple ways, including numbers, words, mathematical language, drawing pictures, using objects, making a chart, list, or graph, creating equations, and they need opportunities to connect the different representations and explain the connections, and use all of these representations as needed, and evaluate the results in the context of the situation and reflect on whether the results make sense. This lesson builds upon that standard 5th grade by not only requiring students to represent their solutions using numbers, pictures, and objects, but also now requiring them to evaluate the utility of models to determine which models are most useful and efficient to solve the problems. This lesson will help prepare them for this mathematical standard in 6th grade, because in 6th grade, they will need to use models to connect and explain the connections between the different representation, which this lesson gets 5th graders to begin to do by representing their solutions in different ways and making connections between those representations to solve the problem in the most efficient way. So this is my lesson and how it connects to all of the standards.